This entire chapter is going to be about rational and irrational numbers, with the first lesson a review in converting between fractions and decimals. However, we're also going to be learning how to convert repeating decimals into fractions. But first, let's review the definition of rational numbers. A rational number that has a clue right in the word. Rational number can be expressed as a ratio. So pretty much that's most of the numbers that we've worked with so far. In other words, if I say 2/7, that's a ratio. If I say the number 3, I can always express it as 3/1, not changing the value, so that's a ratio. If I take the integer -5, I can do the same thing. I also know that the decimal 5/10 is equal to the ratio 1:2, and that the repeating decimal, 0.3 repeat, is actually 1:3. All kinds of rational numbers. And so we're going to review how to go from a fraction to a decimal. Hopefully everyone knows that 3/8 is 0.325. And in fact, because the fraction bar means divided by, in most of these problems for your homework and in life in general, you can always enter into your calculator 3 divided by 8. But just in case you want to review why that is, we would say, does 8 go into 3? No, 0 times. We bring our decimal point straight up, and we add a 0, because 3.0 is the same number. And now I'm going to do long division. 30 divided by 8, it goes in 3 times. That's multiply, 24, subtract, 6, bring down another 0. 60 divided by 8 is 7. That's the divide. Multiply, 7 times 8 is 56. Subtract, bring down, and finally 40 divided by 8 is 5. 8 times 5 is 40. Subtract, bring down. So we've just proven that that's the reason, if you actually do the math out, that the fraction 3/8 is equal to 0.375. By the same token, we know that the fraction 3 repeat the fraction 1/3 is equal to 0.3 repeat. But let's look at why that is. 1 divided by 3. Well, 3 can't go into 1 at all, so again we have to do this. And so it doesn't go into 1, but 10 divided by 3 is 3. 3 times 3 is 9. Well, it doesn't take long to see that this pattern is going to go on forever. And that's why 1/3 is equal to 0.3 repeat. One thing is, if you are going to use your calculators to convert fractions to decimals, it's important to recognize what you've got. For example, if your calculator reads 1.16666, whatever, however many places, 7, it is really talking about the decimal 0.16 with the 6 repeating, which I hope you know is 1/6. This 7 is just your calculator's decision to round up. On the other hand, if you enter 1 divided by 3, you will just get 0.3333333. It doesn't have to round up or down because 3 is less than 5. Know how to change decimals to fractions, but let's just quickly review it. When there are no repeating places, you just have to read it, write it, and reduce it. If we take the example 625 thousandths, that's what I mean by read it. It is a 1 with this many zeros, 1, 2, 3 zeros, so you read the number as though there is no decimal point. And then that is over a 1 with 3 zeros because there are 3 decimal places. And then we have to reduce it, and that becomes 5/8. Some of you might start by dividing by 5 or 25, but you just have to keep going until you have something in lowest terms. It's a different matter, however, when you have repeating decimals. I can't just read 0.3 repeat, for example, because it's not 3/10. It's not 33 hundredths. It's not 333 thousandths. It's something quite very close to that, but not quite. So we need a whole different method. The method that's described in your textbooks is pretty hard to follow, and actually there's no real easy way to do this, but I would like you to at least learn this, because this is easy, and then be able to use it. So if I have one repeating decimal, it's like this, 0.2 repeat, that is 2/9. If I have 0.3 repeat, that's 3/9. And as we know, that reduces to 1/3. We knew this one. If I have 0.4 repeat, that's 4/9, and so on and so forth. So when there is one digit to the right of the decimal place that is repeating, it is always that number over 9. Similarly, if there are two digits repeating, it's that number over 99. Let's say it's 0.45 repeat. That would be 45/99, and then just like with all of these other things, you have to always reduce. That divides, 9 goes into both of those, so it's 5/11. And again, if I say 0.231, that's 231/999. And that actually is divisible by 3. It is, I think, 73/333. So this, whenever all of the digits are repeating, it's really easy. You just have to remember, one digit repeating, 1 9. Two digits in the denominator, 2 digits repeating, 2 9s in the denominator. 3 digits repeating, 3 digits in the denominator. Difficult when when every digit is not repeating. For example, if I say, well, let's talk about 1/6. We know that that is 0.16 with the 6 repeating. So I don't know what 0.1, well, I do, but let's pretend I didn't. I do know that I could write, if I move this decimal point over here, now I have 1.6 repeat, and I know that that is 1 6/9, which is 1 2/3, which is 5/3. Now, unfortunately, that's not the number I started with. It is 10 times bigger because I moved the decimal point one place to the right. So now I have to divide by 10. And since this dividing by 10 is the same as multiplying by 1/10, to divide by 10, all I have to do is put a 0 in the denominator. So if I move the decimal point one place in the beginning, I add 1 0 at the end. So let's see how this works. If I have a number like 4.24 with the 4 repeating. Again, I'm moving the decimal point over one place. That makes it 42 4/9. I now have to change this into an improper fraction. So I do 42 times 9 plus 4, and that gives me, you can check this on your calculator, 382/9. And now, because I moved the decimal point one place to the right, I now have to divide by 10, which is putting 1 0 back. I moved it one place to the right. Now I have 1 0 back. And that reduces to 191/45. There's no need to put these back into mixed. Final one that's a little bit harder. It's going to be 0.3 with the 2 1 repeating. So the first thing we want to do is move the decimal point to the repeating section. I'm just going to call them to the repeats here. That means I'm moving it one place to the right. Now I have to express this as a mixed number. And that would give me 3 and 21/99. Two repeating digits means 2 9s. I then want to reduce because anytime I can simplify, it will make it easier. So that makes that 3 and 7/33. Now I want to express as an improper fraction. And that gives me 106/33. And since I moved it one digit to the right, that means I'm going to add 1 0. And when I reduce that, add zeros to, I think there's any in there, to denominator. And remember, as many as moved in step 1. And finally, you want to reduce. So that equals 53 165ths. By more. And I don't have a calculator available, so we're just going to do our best here. Let's see, what do we want to do? Let's say it is 0.24, and then 3, 6 with the 36 repeating. So now we have to move this over to the part that's repeating and express it as a mixed number. That gives me 99ths. I do want to reduce this, and that gives me 12, because 36 divided by 3 is 12, 99 divided by 3 is 33. Now, I need to express this as an improper fraction. So 24 times 33 is 792, plus 12 is 804. So this is 804/33. Now, this time, since I moved it over not one place, but 2, I now need to add 2 zeros at the end. Using divisibility rules, I can tell that these are both divisible by 3. The bottom is 1100, but let's see. 804 divided by 3 is 268. I can see that these are both divisible by 2. So that's 134, and that's, let me think, that's 550, and they're still divisible by 2. So that's now 275 on the bottom, and 67 on the top. And that is our final answer. Turns out reducing was the hardest part of all. Anyway, this is a semi-tricky procedure, but it's easier, I think, than the way the textbook describes it.